All right, in this lesson, we are going to graph log functions using transformations. And so first off, this is transformation form. If you see an equation like this subscript here is just the base. It is not a transformation, it is not a reflection, it's just the base of your log. So we are going to look at log base 2, but we're also going to look at log base 5. And so being able to identify the base is very, very important for this. Next, this multiplier out front, that is going to be your vertical stretch, your vertical compression, or your vertical reflection across the x-axis. This multiplier inside the log, inside the argument, is your horizontal stretch, your horizontal compression, and your horizontal reflection across the y-axis. This C value is your right and left. And remember, everything inside the log, inside the argument, inside the parentheses is opposite. And then D is up and down. Okay, and so looking at the parent function for log base 2, we need to think about what his inverse, 2 to the x, would look like. And so for the exponential function that has a base of 2, if we plug in 0, we have 1. If we plug in 1, we get 2. If we plug in 2, we get 4. Okay, so that situation is going to be completely reversed for log base 2. These are inverses. And so when we make the table for that, it's going to be switched. The x's and y's are switched. So we're going to have our 1, 2, 4, and our 0, 1, 2. Okay, and so if I graph this, I have 1, 0, I have 2, 1, and then I have 4, 2. Okay, and so this function is kind of going up to the right. It looks a lot like our square root function, but it is actually going to have what I call a tail that goes down towards the x-axis. We can't plug in 0 and we can't plug in negatives because we have a vertical asymptote at x equals 0. Okay, so I'm going to use a highlighter. This is an invisible line, and so you can do it dotted or you can use a highlighter. It doesn't actually get graphed. You just see the function approaching. So it's a vertical asymptote at x equals 0. Exponential functions have a horizontal asymptote that we keep track of. Log functions have a vertical asymptote that we keep track of. Okay, and so that's why when we check for extraneous solutions for log, we make sure the argument is positive. You can't plug in 0, that's where the asymptote is, and you can't plug in anything to the left. This entire function is to the right of the asymptote. And so when we list some of our key features, the critical point that we keep track of is the x-intercept at 1, 0. And then the asymptote that I just graphed is x equals 0. X equals each time. The domain is to the right of the asymptote, so 0 to infinity with a parenthesis. That's the positive values. And then our range this time is all real numbers. So notice this is completely opposite of what we did with exponential. Okay, and so when we graph this a lot like we graph exponential. You're going to graph the asymptote first, and then if nothing else has happened, you're going to have a point that is 1 away, and then your next point up will be the base away. And then your next point up from there is going to be your base squared away. So right now you're seeing a distance of 1, a distance of 2, and a distance of 4 from the asymptote. You're always measuring from the asymptote. If this was base 3, I would see 1, 3, 9 for those distances from the asymptote. Okay, and so that will help us graph each of these parent functions or each of these transformations. Okay, and so starting with this first example, this is log base 2. And then to identify the transformations, I have a vertical stretch by 2. I have a right 3. And I have an up 4. Okay, and so the only transformations that are going to affect the vertical asymptote is left and right. And so now my vertical asymptote is at x equals 3. Usually it's at 0, but we're moving it right 3. Okay, and then since this is base 2, my x-intercept is now 1 away from this asymptote, so now it's at 4. My next good point for base 2 is going to be a distance of 2 away, and then my next point is going to be a distance of 4 away. Okay, that's if we only moved it right 3, but we also moved it up 4. So I'm going to take these points and I'm going to move them up 4. So usually we're on the x-axis. Now we're 1, 2, 3, 4 up. Okay, and so then when you're making your graph, because we have a vertical stretch by 2, these points are usually a distance of 1 vertically away. We're actually going to go up 2 between the points. And so this point would be up 2 from my original critical point, and this point would be up 2 from that previous point. Okay, there needs to be a vertical distance of 2 between each of your points. Okay, but we still have the distance of 1, distance of 2, distance of 4. Okay, and so then when you graph up to the right, down towards the asymptote. Okay, and so our vertical asymptote we said is x equals 3. Domain is to the right, and so we are going from 3 to infinity, and then range is all real numbers all the time. All right, in this next example, we have a b value here, and we also have a c value. Anytime you see that, you need to make sure you have 2 sets of parentheses. So my first step is to factor out the 1/2. So add a set of parentheses and divide your c value by whatever your b value is. Okay, and so when I rewrite this in proper form, I'm going to have the 1/2 and then a second set of parentheses, x plus 6. 3 divided by 1/2 is 6. And then you can picture, if I were to distribute the 1/2 back into those parentheses, I would get 1/2 x plus 3 again. And so we're basically undistributing that 1/2. Okay, and so this 5 down here is your base. We are working with base 5. Okay, and so my distance from the asymptote is going to be 1, 5, and then 25, which won't fit on our graph. So we'll just focus on the 1, 5 pattern. Okay, and so for the other the only transformations we have are a horizontal stretch by 2. Remember, everything inside is backwards. We have a left 6, which moves the vertical asymptote to x equals -6. And then we have a down 2. Okay, and so the horizontal stretch by 2 is going to change my 1, 5 pattern to a 2, 10 pattern. Okay, so when I make my graph, start with your vertical asymptote at x equals -6. And then if nothing else happened but that left 6, I would have a 1 away point, and then I would have a 5 away point. Okay, and so because of the stretch, it's now 2 and 10. So I have a 2 away point, and I have a 10. And the vertical distance is still 1 because we don't have a vertical stretch or compression. Okay, and so the last thing we need to take care of is the down 2. And so we need to shift the x-intercept down 2, and we need to shift this point down 2. Okay, so we've taken care of the horizontal stretch. The left 6 we did first, and then the down 2. So up to the right, kind of like square root, and then a tail down towards the asymptote. Okay, and so domain -6 to infinity because we're to the right of the asymptote, and then range all real numbers all the time. Okay, for this next example, you're not seeing a subscript on the log. That means it's common log with a base 10. Okay, and so my distance from the asymptote is going to be 1, 10, and then 100, which absolutely will not fit on the graph, so we just need that 110. Okay, for our transformations, we have a reflection across the x-axis, and we have a vertical stretch by 2. We have a right 1, which means our vertical asymptote is x equals 1. Starts at 0, right 1 puts us at x equals 1, and then my last transformation is up 4. Okay, so start with your vertical asymptote, right 1, at least get that in the right place. So after we graph the vertical asymptote, the next point we would have is our 1 away point and then our 10 away point, which would be off our graph. But this has been reflected across the x-axis. So instead of this 1 away point being up here, it's going to be down here below the axis. The x-intercept doesn't move. It still stays on the x-axis because we reflected over the x-axis. So the x-intercept stays. That's why it's important that you do your reflection and then start translating up or down, because now we can take care of the vertical stretch by 2, which means our points are 2 vertically away. And so we need to move this a distance of 2 away from my original point. So we have our reflection, we have our vertical stretch by 2, we've already done the right one, now we just need to shift these up 4. So 1, 2, 3, 4. Okay, and so because of the reflection across the x-axis, our function, if you're pretending it's like square root, it's going to be upside down, and then his tail is going up towards the asymptote. That's how you're going to recognize the reflection. Okay, we're still to the right of the asymptote, so our domain is 1 to infinity, and then our range is all real numbers all the time. Okay, this next one, there's a lot going on here. It says ln, which we know is log base e, and then our x should be written first, followed by our translation here, that +4, which also tells us we need to add our parentheses and divide by that -1. And so the better way to write this in order to graph it would be x -4 in those parentheses and then -5. So we're working with base e, which is approximately 2.7. We have a reflection across the y-axis. We have a right 4. And then we have a down 5. Okay, so it's going to be hard to get very accurate with our points here because E is not a whole number, but we're going to do the best we can. Starting with the vertical asymptote, that is now at x equals 4 because of the right 4. And so I'm going to put that on my graph. And then we have a reflection across the y-axis. So usually I would have a 1 away point right here on the x-axis. We're reflected, And so it's going to be to the left of the asymptote. And we've already done the right 4, and now we just need to move it down 5. Okay, so there's my 1 away point. And then my next good point to go up 1 and then a distance of e. So up 1, a distance of e is about 2.7, so not quite 3. And then our function is still going up, but now to the left, and tail is still down towards the asymptote. The only time your tail is ever going up is if there's a reflection across the x-axis. Here we just had a reflection across the y-axis, so the tail of this function should still be going down towards the asymptote, but now he's facing left. And so our domain this time is to the left of the asymptote, so negative infinity to the 4, and then range is still all real numbers. This function goes up forever and down forever. All right, on this last page, the function f of x equals natural log of x is transformed to g of x. List the transformations, domain, range, and asymptote. So here we have a reflection across the x-axis, a vertical reflection, and then we have a vertical compression by 1/4. Jumping inside the log, we have a left 7 and a down 3. Okay, so those are our transformations. For our domain, we are still going to be to the right of the asymptote. There's no reflection inside, and so our domain is going to go from 7 to infinity, while our range is always going to be all real numbers. And then the vertical asymptote is x equals that, oh, it's left 7, sorry, negative 7 is negative 7 with the x equals in front of it. Okay, so now they're giving us a graph and we need to write the equation for it. So the first thing I like to do is graph the vertical asymptote. Look at where the function is looking vertical. And so here we see a vertical asymptote at x equals 6. And so I know this function has been moved right 6. Okay, next it is to the left of the asymptote. So I know there is a reflection across the y-axis. And then looking at my points, my 1 away point is now shifted up 4. Okay, and so I know this function has been moved up 4 because this 1 away point should have been on the x-axis. And so if it's up 4 units, that's how I know it's been shifted up 4. Okay, and so the next point goes up 1, and then the distance from the asymptote from 6 to negative 4 is 10. Okay, so I have a distance of 1, then 10, and so I know this is base 10. Okay, and because this is a distance of 1, I know there's no vertical stretch. Because I have a 1 away point, I know there's no horizontal stretch. So it is base 10 with these 3 transformations. And so I know I'm going to have log base 10, which we don't write the 10. Okay, we leave that invisible. I'm going to write it for right now just so you can see where it's coming from. And then we have a reflection across the y-axis. That means my negative is inside. Add a second set of parentheses to do your right 6. Close both parentheses, and then a +4 at the end. Okay, and so I'm going to get rid of this base 10 because we leave that invisible for base 10. Base 10 only is common log. And so my equation is y equals log of negative quantity x minus 6 plus 4.